for the value panel model. So the deviation of cross sections data. So if the cross section is data is something like that, so in the x-axis you will have your offsets, and the y-axis you will have the height. So let's think about the point where, let's say it's x and HA. The offset is x and the actual height is HA. Let's imagine during the measurement procedure you will have HM measured. Now you can see there is a variance or the difference between the actual value and the measured value, and you will come up with a positive percentage of discrepancy in here. But rather than having the red case, let's see about what will happen in blue case. So you will have H measured as a lesser value rather than the actual value. So here you will come up with a negative percentage of discrepancy. So I will define my percentage of discrepancy as follows. The percentage of discrepancy is the difference between the actual and the measured value as the ratio of the actual. So this is only for a particular point. So let me describe about the positive percentage of discrepancy. If this is the actual data, let's see how it is vary about 25% of discrepancy positive value. Now this is 50. Now this is previous one not 35. Now this is 50. Now you have to be careful here, since my elevation 0 or the 0 elevation point is at the river bank. So because of that, if I am going to increase a positive percentage of discrepancy, the river banks or the adjacent lands area get much higher. Now you can see here the value is 4, and if you put 50% of discrepancy, it will something close to 6. But at the same time, the river banks gets higher elevation, but at the same time the canal area get much deeper. So that is because of my 0 elevation is at the river bank. So let me see what will happen in the negative percentages. So if it's the negative percentage 25, it's getting shallower. The channel area gets shallower, and except same thing happen right at the positive percentage of discrepancy. So that I have described the cross section, how I am going to change the cross sections. Then the scenario modeling, how I am going to come up with several scenario modeling. So as I mentioned earlier, I have a 2.6 kilometer with 50 number of cross section. I am not going to change all cross sections data. I have selected 3 particular cross sections, and then I am going to vary the cross sections data as I mentioned earlier by giving a percentage of discrepancy. And the scenario modeling includes case 1 and 2 and 3, where in the case number 1, I am going to select the 12 cross sections, and I am going to give 15 positive 50%, positive 35%, positive 25%, and same for the negative values. So in the case 1, I have 6 scenarios to be modeled. In the case 2, I have a combination of cross section 12 and the 8. And then the scenario model for the color wire, similarly, I have 3 cross sections, and for these things as well, I have scenario models with another 5 cases where, similar to the value panel model, apart from those 2, I have come up with another 2 sections with a combined simulation model. So then let's see how its analysis part. So in this particular case, steady flow analysis was done, and for the continuity analysis, percentage of water surface increment and the mean absolute ratio error is calculated. So percentage of water surface increment is, when I run a model for the scenario, what is the height I am going to receive, and the original value, the difference of that. And the mean absolute error is for a particular case. Percentage of water surface discrepancy is for a location, but the mean ratio of absolute is for a whole stretch of interested water body. So let's see if the original condition is mentioned in the light blue color. If once the scenario model is done, if it is 50% of discrepancies condition is done, it is indicated in the dark blue color. So here the difference will be quantified, and then I will come up with the MARE value and the PWSI value. So then I am going to present you the results. So those are the cases I have considered. So in the case number 1, negative percentage of discrepancy, I have changed the cross sections data at cross section number 12, and now you can see the percentage of water surface increment effect right from the beginning up to a 2 kilometer stretch. You are only changing the cross section at the cross section number 12. The chain edge value is something like close to 600, but that particular effect will be indicated at the 2.5 kilometers as well. Now you can see the variation is around 10%, 15%. at the negativity, you will have a lesser value. And this is for the case number 3, where you have deviate 3 cross sections data. And for the results for the Holloway model, this is somewhat different from the previous one. Why? Here I have model 11 kilometers, and my effect is somewhere very narrow. And this is for the case model results for the Holloway as well. And coming back to conclusions, so PWSI were calculated, and it is in the range of 16 to 4%, and for the Holloway model it is 35 to 15%. Now this one would give you idea, if you have lesser cross sections data, whatever the variation that you are going to make is much significant. And the second one is water surface profile were influenced at the both upstream and the downstreams, and purposely deviated cross sections model into the developed hydrodynamic model. And third one is, however, the water surface profile will show you a mean absolute ratio of error is only about 6%, although you deviate the cross section from -50 to +50%. And this one give you the idea about MARE values. It is always less than 6%, even for the Holloway model as well. So, as acknowledgement, I would like to make my appreciation for the Professor NTS Vijaysekara, who guided us about the water surface modeling, and during the development of those models, survey department and the SLRCC authority gave us a biggest support, and the ability to develop these kind of models through freely available software, Hydrodynamic is very much appreciated. So, thank you very much.